We are doing a deep dive today into a word that is, well, just completely loaded. Power. It's everywhere. You talk about it in politics, you analyze it in relationships, you even measure it coming out of your wall socket.
It's a true shapeshifter of a word, isn't it?
Yeah.
And today, we've got these two completely separate stacks of source material.
Yeah.
And they define that exact same word in ways that seem, almost mutually exclusive.
Right. One stack is all physics. It's precise, it's quantifiable, something we can literally measure in joules per second.
And the other stack? It's pure philosophy. It defines power as this huge, pervasive force, like an ocean that's in the air between us. That's the world of Michel Foucault.
So our mission for this deep dive is to unpack both of these worlds. First, we'll get a really solid grip on the scientific meaning of physical power and, trace it back to the Industrial Revolution.
And then we're going to pivot hard into Foucault's very abstract, very different theory of social power.
The idea is that by comparing them, you'll get this unique lens on how a single critical term can operate in totally different domains. If you want to sound smart about both engineering and critical theory, this is definitely the deep dive for you. Okay, so let's start with the basics, the quantifiable world of classical physics. To get to power, we actually have to start with work and energy. They kind of build on each other.
That's essential, yeah, because the everyday definition of work, like, answering emails or writing a paper, is completely different from the physics definition.
So how do our sources define it? What's the scientific take?
Work in physics only happens when you apply a force to an object and that object moves a certain distance.
Yeah.
And this is the key part. It has to move in the same direction that the force is being applied.
Right. So pushing a cart forward, that's work. Okay, let's use that classic example, the one that really makes this click. What's something that feels like a ton of work but isn't?
The best one is carrying a heavy box or a stack of bricks across a flat parking lot at a steady pace. You're straining, right? You're exerting a huge upward force to counteract gravity. But you aren't moving the bricks up, you're moving horizontally. And since you're moving at a constant speed, there's no net horizontal work being done either. So you're exhausted, but in the language of physics, zero work.
That is the aha moment right there. Work needs displacement caused by the force. And from there, we get to energy.
Energy is simply the ability to do that work. They're really two sides of the same coin. They even share the same unit of measure, the joule, named for James Joule.
And the rule that connects them is the Work-Energy Theorem.
Exactly. It just says that when you do work on an object, you change its energy. The net work you do is equal to the change in its motion energy, its kinetic energy. So if you push a car, the work you do makes it go faster.
And kinetic energy, the energy of motion, is the counterpart to potential energy, which is stored energy, like a stretched rubber band or a book sitting on a high shelf.
Right. That book has stored gravitational potential energy. If you knock it off the shelf, that potential energy converts right back into kinetic energy as it falls.
Okay, so this whole structure work, energy, it all builds up to the concept that really changed the world, power. And power isn't about how much work you do, but how fast you do it.
It's the rate. That's all it is. Power is just work divided by time. The unit is the watt, named, of course, after James Watt.
Let's use that thought experiment from the source material to make it intuitive. The two people moving a TV.
Sure. So they're both moving the exact same television to the same fourth-floor apartment. They've done the exact same amount of work, physically speaking.
But one of them uses a pulley and gets it up there in 2 minutes. The other one hauls it up the stairs and it takes them 5 minutes.
The person with the pulley generated more power. Way more. They did the same work in less time. They just crushed the denominator in that equation.
And this focus on the rate of work is James Watt's real legacy, isn't it? It's more than just his name on a light bulb.
Oh, absolutely. His genius was solving inefficiency and application. Before Watt, steam engines were these horribly inefficient beasts. They wasted most of their steam just reheating the cylinder every single stroke. His separate condenser solved that.
But the real game changer was converting that piston's up and down motion into circular motion.
That was everything. Up and down motion can pump water, sure, but circular motion kind of turn wheels, drive belts, run looms. It can run a whole factory. That's what enabled the Industrial Revolution. Watt didn't just define power. He unlocked it at a scale that remade civilization. Now, that same concept of rate and efficiency gets a lot more complicated when we look at modern electrical systems.
Right, because with simple DC, direct current, the math is clean. Watts equals volts times amps. It's straightforward.
But our grid runs on AC, alternating current. And with AC, the voltage and the current are very rarely perfectly in sync. So we have to introduce this other variable into the equation called the power factor.
So the formula gets an upgrade. Watts equals volts times amps times this power factor. So what do you call just the volts times amps part, and why does it need to be adjusted?
The simple product, volts times amps, is called apparent power. But what you really care about is the active power, or real power. That's the stuff that's actually doing useful work, and that's measured in watts.
So the power factor is kind of a measure of slippage then. It's telling you how much useful work you're actually getting for the total amount of juice you're sending down the wire.
That's a perfect way to put it. Yeah, it's a slippage factor.
Right.
When it's low, it means the current and voltage waves are out of phase with each other. This usually happens with big industrial loads like AC motors. They create what's called an inductive load, which causes the current to lag behind the voltage.
And why should someone listening care if their current is lagging? What's the big deal?
The big deal is that a low power factor means you're pulling more current from the grid than you actually need to do the job. All that extra current is just wasted as heat in the wires. It strains the equipment. If you're a utility, you hate it. And if you're a big industrial customer, they'll actually charge you more for it.
So it's an efficiency problem. Just like Watt with his separate condenser, engineers today have to find ways to correct for this lag.
Exactly. And since most of those big loads are inductive, causing a lag, the fix is usually to add capacitors. Capacitors create the opposite effect. They make the current lead the voltage. So you use the capacitors to cancel out the lag from the motors, get everything back in sync, and push that power factor back up towards 1.0.
So it all comes back to maximizing the rate of useful work. It's just that the internal dynamics of the system make the calculation a lot trickier.
Okay.
We have nailed physical power, we get the watt, we get the joule, and we get this engineering drive to eliminate lag and maximize output.
And now, it's time to make probably the sharpest conceptual pivot we possibly can. We're going to ditch all of those units, all that math, and enter the philosophical world of Michel Foucault.
Right, and Foucault just completely rejects what he calls the legalistic view of power, the idea that it's a thing, a commodity that a king or a government has and then uses on the powerless.
He says that whole model is useless. If power were a thing you could hold, you could seal it or redistribute it. He says, no, that's not how it works at all. He uses this metaphor of the ocean. Power is an oceanic force. It's everywhere, all the time, circulating.
So if it's not held by a person, where does it actually live?
It lives in the relationships. He calls them force relations. Those are the atomic units of his model. Power exists in the potential for interaction between any 2 points in a social network. So every single interaction, from lovers to tyrants, is an expression of this force.
That sounds almost mystical. But the sources highlight two really clinical-sounding terms for it. Immanent and non-subjective. What do those actually mean?
Okay, so if power is immanent, it means it exists inside the system. It's not some force from on high, like from God or the soul of the king. It's generated from within the social fabric itself, moment by moment.
So it's baked into the language we use, the buildings we're in.
Precisely. And non-subjective is just as important. It means the expressions of power are never really personal. The system might produce a bully, but the power isn't the bully's personal malice. It's the spontaneous pressure of the whole system. The ocean doesn't have a personal agenda when a wave crashes.
That is a huge mental shift. We're so used to thinking of power as deliberate, as something someone wields with intention.
And Foucault would say that our very intentions are often products of this non-subjective force. That's why his historical work, like his famous book on prisons, discipline, and punish, he didn't call it a history, he called it a genealogy. He was tracing how this oceanic power slowly crystallized into the institutions we recognize.
Like schools and hospitals and the military.
Exactly. They all use similar techniques of discipline and normalization. And this gets to his most famous idea, knowledge power. For Foucault, knowledge is never neutral. The act of creating knowledge, like defining what's sane versus insane, simultaneously creates and reinforces the power structure that gets to use that definition.
This sounds incredibly bleak. I mean, if the system is everywhere and our own thoughts are just a product of it, what's the point of this theory? It's clearly not a manual for how to win.
It's not. The goal isn't personal empowerment in that way. The sources suggest the goal is to give the reader tools to pay attention. It's a highly sophisticated map of control. By understanding the microphysics, you're just better able to see how your own reality is being constructed around you.
But there's a huge dilemma built into that, right? If my very act of resisting is just another wave in the same ocean, another manifestation of power, then what can I even do with that knowledge?
That's the trap. You can map the ocean you're swimming in, but you can't, just step out of the water.
So that brings us right to the synthesis. On one hand, we have the world of James Watt. It's all about efficiency, speed, getting the maximum output. And on the other, we have the world of Foucault, which is about analyzing these invisible relational forces that control everything.
And they meet on that shared word, power, which in both cases describes some kind of fundamental rate or dynamic.
Right. Physical power is the rate of energy transfer joules per second. You master it with engineering, with a separate condenser, or by fixing your power factor.
And philosophical power is the dynamic of force relations in society. You master it, if you can, through critical awareness, through, just paying attention.
What's so fascinating is how their goals diverge. Physics is fundamentally optimistic. It's about maximizing a rate, making pyras as big as possible. It's practical.
Whereas Foucault's analysis is, well, it's almost inherently pessimistic about the individual's ability to change things. It's about seeing the grid of control and maybe accepting the limits of your own intentions.
It really boils down to this idea of optimization. In physics, you optimize by making the denominator time as small as possible. You win by being faster.
But in Foucault's oceanic system, how do you optimize? We already said that resistance is just another expression of power. Some critics say that if you can't fight the ocean, the only way to win is to give up the desire to win, to just float.
And that's the core tension, isn't it? Foucault gives us this incredibly detailed map of the social currents and traps. But if he's also right that our desire for our own work and energy is just a product of that same system,
then it leaves you, the person listening, with this final thought to chew on. If you use Foucault's map to understand your social world and Watt's principles to maximize your output in the physical world, how do you reconcile them? Does mapping the philosophical ocean give you any real power to be more efficient in your life? Or does it just prove that the faster you try to run, the tighter that grid of power relations ultimately holds you? Something to think about.